cosmic secrets revealed. Beyond time, beyond space, beyond imagination.
Billions of years from now, the universe will face its end, not with a cataclysmic fire or a deafening explosion, but with a silent, endless, and profound freeze. This is the chilling story of the Big Freeze, the most widely accepted theory for the ultimate fate of everything we know. So what exactly is the Big Freeze? You might have also heard it called the heat death of the universe. It's the idea that the universe, which started expanding with the Big Bang, will just keep on expanding forever. Imagine pouring a drop of hot water into a vast, cold ocean. The heat doesn't stay concentrated. It spreads out until the entire ocean's temperature is barely changed. The Big Freeze is a similar concept on a cosmic scale. As the universe expands, all the energy within it spreads out more and more thinly. Stars burn out, galaxies drift apart, and everything just gets colder and darker. Eventually, all energy will become so evenly distributed that there's no difference in temperature anywhere. And when there's no flow of energy, nothing new can happen. No work can be done. It's the ultimate state of equilibrium, a universe frozen in stillness. Right now, if we look out into the cosmos, we can see that galaxies are moving away from each other. And not just moving away, but accelerating. The space between them is literally stretching, and this stretching is getting faster and faster over time. This incredible phenomenon is driven by a mysterious force that scientists have named dark energy. We don't know what it is, but it acts like a kind of anti-gravity, pushing everything apart. As this relentless expansion continues, galaxies will drift further and further from each other. Imagine standing in a city at night and seeing the lights of other cities on the horizon. Now imagine those cities are all moving away from you, so fast that eventually their light can no longer reach you. One by one, they would vanish from your sight. That's what will happen to the galaxies. The cosmic neighborhood will become a lonely place, until our own galactic cluster is the only thing left in our observable universe. Now, let's fast forward a few trillion years. The universe will have become a much darker place. The last stars, the long-lived red dwarfs, will have finally exhausted their nuclear fuel. The brilliant, fiery beacons that have illuminated the cosmos for eons will sputter and die out. The night sky, as we know it, will turn completely black. The remnants of stars, like white dwarfs, will slowly cool down over unimaginable timescales, radiating away their last vestiges of heat until they become cold, dark husks known as black dwarfs. The great cosmic theater, once filled with the drama of stellar birth and death, will finally go dark. The curtain will fall on the age of stars, leaving behind a silent graveyard of cosmic embers. As the expansion continues unabated, the universe becomes even more desolate. The galaxies themselves will begin to dissolve. Stars will be flung out into the intergalactic void, and the remaining matter will be swallowed by the supermassive black holes lurking at the center of each galaxy. For a time, these black holes will be the last remaining giants of the cosmos. But they are not eternal. Over timescales that are almost impossible to comprehend, longer than the current age of the universe by many, many orders of magnitude, even these gravitational behemoths will slowly evaporate. They will radiate away their mass through a process called Hawking radiation, a faint quantum glow. One by one, even the mightiest black holes will shrink and finally vanish in a final, quiet pop of energy. With the last black holes gone, we arrive at the end of thermodynamic time. All usable energy has been spent. Entropy, the measure of disorder, has reached its absolute maximum. There are no stars, no light, no heat, just a near-perfect vacuum filled with a sparse soup of fundamental particles like photons and neutrinos, all drifting aimlessly in a cold, dark universe approaching absolute zero temperature. In this state of ultimate equilibrium, nothing changes. There are no events. The arrow of time, which points in the direction of increasing entropy, loses its meaning. When everything is the same everywhere forever, does time even exist? It's a profound question at the very edge of physics and philosophy. The universe will have reached its final, static, and eternal state. Now, it's worth noting that the Big Freeze isn't the only theory about the end of the universe. For a while, scientists considered the Big Crunch, where gravity would eventually overcome expansion and pull everything back together into a fiery singularity, like the Big Bang in reverse. Another more violent idea is the Big Rip, where dark energy becomes so powerful it tears apart galaxies, stars, planets, and even atoms themselves. But compared to these dramatic endings, the Big Freeze is slow, methodical, and silent. It doesn't destroy the universe in a violent cataclysm. It simply lets it fade away into cold and darkness. Based on our current understanding of dark energy and the accelerating expansion, this quiet end is what most cosmologists believe is the most likely scenario for our cosmos. The universe began with a bang, and it seems it will end with a whisper. The story of the Big Freeze is more than just a scientific theory. It's a humbling reminder of our place in an ever-changing, impossibly vast cosmos. It shows us that everything we see, the brilliant stars, the sprawling galaxies, and even time itself, is ultimately temporary. We are living in the vibrant, youthful era of the universe, a fleeting moment of warmth and light. Thank you so much for joining me on this journey to the end of time. If you found this as fascinating as I do, please consider liking the video and subscribing for more explorations into the mysteries of our universe.